it would be informative to examine a popular tabletop demonstration purported to show the heat-trapping properties of carbon dioxide in Earth's atmosphere. This is the so-called greenhouse effect in a bottle experiment, frequently used to teach students about how the anthropogenic global warming is supposed to work. Here is an example. First, let's answer the question, what made the bottle filled with carbon dioxide warming up more than the control bottle containing normal air? Well, the CO2 bottle absorbed more infrared radiation from the sun lamps than the air-filled bottle. This part of their explanation was correct. Since gas volume is constrained by the rigid walls of the bottles, gas expansion and convective heat exchange with the surrounding environment were hampered in both cases. But because CO2 absorbs more thermal energy than air, it also expands stronger than air. As a result, the gas pressure in the CO2 bottle rises to a higher level than the pressure in the air-filled bottle. This boosts the temperature in the CO2 bottle above that of the air-filled bottle. However, this does not demonstrate a heat-trapping property of carbon dioxide. Here is why. Gas systems operating under a fixed volume, as in this experiment, are called isochoric in thermodynamics. Their behavior is described by the Gay-Lussac law, which states that in a constant volume system, pressure is proportional to temperature. One can also state that in isochoric system, temperature is a linear function of pressure. However, the atmosphere is not an isochoric system because its volumetric expansion is not constrained by a rigid barrier. The atmosphere operates as a constant pressure system, also known as isobaric system, because the surface pressure is determined by gravity and the atmospheric mass above a unit surface area. Isobaric systems are governed by Charles' law, which states that under a constant pressure, gas volume is proportional to temperature. One can observe Charles' law at work in Earth's atmosphere by examining the latitudinal variation of the height of the tropopause. Tropopause is the altitude where vertical convection induced by surface heating runs out of energy and ceases to push the cloud deck any higher, while at the same time making the air temperature stop decreasing with elevation. That is, the elapse rate becomes zero in the tropopause. The tropopause height is an indicator of atmospheric volume. In the tropics and subtropics, the tropopause is located at 16 to 18 kilometer altitude, while in the polar regions it is found at 8 to 10 kilometer altitude. This suggests that the atmospheric volume is nearly twice as big in the tropics as it is at the poles. That's because the solar heating is much stronger at lower latitudes than it is in the polar region. Air parcels heated at the surface rise and cool adiabatically in the free atmosphere by expanding into lower pressure levels aloft. However, a gas trapped in a bottle cannot cool through expansion. Impeding convective heat exchange and adiabatic expansion makes the results from this bottle experiment inapplicable to the real atmosphere, since bottle gases represent a completely different kind of a thermodynamic system governed by a different law compared to the gas system of an open atmosphere. If a CO2 parcel would be allowed to freely expand when heated by infrared radiation, its final temperature will be no different from, or perhaps even cooler than, that of an unconstrained parcel of normal air absorbing even lesser amount of infrared radiation. Therefore, this bottle experiment demonstrates nothing more than the well-known Gay-Lussac law of thermodynamics and does not provide an illustration of radiant heat trapping by CO2 as claimed by the current theory. Another problem with the experiment shown in this video is that the greenhouse bottle contained over 80% carbon dioxide, since it was capped immediately after pouring the vinegar that started the chemical reaction releasing CO2. The Earth's atmosphere currently only has about 0.04% carbon dioxide, that is expected to rise perhaps to about 0.06% by the year 2100. Over the past 500 million years, atmospheric CO2 has not exceeded 0.25% or a quarter of a percent. The CO2 concentration in the experimental bottle is over 300 times higher than that. This makes a big difference in how much warmer the greenhouse bottle could get. If the control bottle contained a pre-industrial CO2 concentration of 0.028% and the greenhouse bottle was at the present CO2 level of 0.0415%, then even this constant volume experiment would likely have shown no measurable difference in temperatures between the two vessels. However, for some reason, such experiments are not performed publicly.